In this video we'll be continuing with the C# tutorials. So hopefully there isn't too much wind noise because I've lost my mic foam somewhere around me. It should turn up pretty soon. Alright, so last time in the playlist we went over decision structures, control structures. So we focused on the single alternative decision structure. So now we'll talk about Boolean expressions and relational operators. Alright, so Boolean expressions are named in honor of the mathematician George Boole from England in the 1800s. So he developed Boolean math. So that's where computer science was derived from. Well, like a big part of it. Because obviously Booleans are like true or false is a very powerful concept in computer science and electrical engineering. And it goes into switchboards and stuff, like electrical circuits and all that, I think. So pretty much a Boolean expression that is tested by an if statement is formed with a relational operator. So what is a relational operator? You've seen these around in math. They probably called relational operators as well. But in computer science you can use them to compare strings, which are again based on math, but nothing complicated. The math isn't too complicated. We may be focusing on some more advanced computer science math topics later on. Nothing too complicated though. Perhaps we'll be getting into some more harder math, but nothing. It shouldn't be too bad. It might be a bit complicated, but not. We'll talk about that later. So relational operator determines whether a specific relationship exists between two values. So it determines whether a specific relationship exists between two values. So we have more relational operators. So this isn't a relational operator, but so we have the greater than symbol. I'll just go with I'll just say this is the greater than symbol. You've seen that before, obviously. I hope, because if you don't, you should know pretty much this kind of math stuff. Greater than, less than or equal to, greater than or equal to, is equal to. There might be a few more. So we'll talk about that in a sec. So this is a greater than symbol. Obviously we have then a few more. So we have equal to. Which determines if the two values are equal. So we'll talk about these, pretty much all of them. So an example of the greater than symbol in a computation, pretty much. So we have, for example, val1, or just val is greater than val2. You could throw this in a if val is greater than val2, if val is greater than val2, then I want to do something. If it's not, then I can't. Then I don't want to do something. Right. So then if we have, so we'll just throw a less than in here. We won't talk about all of them. We'll talk about, actually, like, we won't get into detail on all of them because obviously they're pretty self-explanatory, but we have less than, greater than or equal to, less than or equal to, and then not equal to. This might be the one to remember here, is just an exclamation sign and an equal sign. Can be a little tricky to remember if you're just starting out. Once you start out, you'll get them eventually. I think you can compare strings like this in Java, but in C#, but you can't compare them in Java like this. I think I kind of forgot. I haven't coded Java in a bit here. You can always try it out though, if you need to just test something. If it gives you an error, then you can't do it. If it doesn't, then you can do it. You'll find yourself probably forgetting, if you're cycling through a bunch of languages, what you can't do and can do sometimes. You can just always just check. You can set a breakpoint for later on, or you can just run the code after the line to see if it works. But this is greater than or equal to less than or equal to, not equal to. So for example, let's go with the opposite then. So if val is less than or equal to val2, which is self-explanatory, then do something. So this is if val1 does not, if val does not equal val2, then do something. If val is equal to, you've seen this before, if val is equal to val2, then do something. So pretty easy to remember. The last one might need to kind of just practice that one. So pretty much we can skip most of this. It's pretty self-explanatory. Yeah, it's pretty self-explanatory. We don't really need to get into depth about these. You've seen them before. Maybe this one you might want to practice. Is equal to, you'll have to get used to that, obviously. These two. The other four you've used in math for sure. In normal math it would just be like this. Just one equal sign, but that means usually like points to. So just be careful with that. This can always mean point to as well, but or set to. So I know a lot of coders also say set to on YouTube as well. But anyways, so we'll just do one example here. So if, for example, val is greater than some large number, then we want to set val2 to point to that number times 10 something, whatever you want, something like that. Otherwise it won't multiply that number by 10. Or you can just assume that number is like decimal val. And then here, if val is greater than decimal val, then we want to set decimal val times 10. Probably might give you an error. Something like that. That's pretty much it. Alright, so now we'll talk about pretty much a single alternative conditional statement. Is that what we called it? Single alternative decision structure. Okay, so that's pretty much it. I don't think we need to do this example. But you could again set this to, you could just set here like some more things. Then you could set val2 to point to 5, and set val2 to point to 4, whatever you want. So that's kind of basically what we learned already, single alternative decision structure. The single alternative decision structure. So your compiler will automatically indent in most cases, so Rider does and Visual Studio does. You don't need it, but it's a good practice. Alright, so that's pretty much it. We'll probably be getting into a lab now, more so GUI lab, pretty much. Okay, this one's gonna be kind of big because it's gonna have a group and a panel, I think, or at least a group or a panel. Actually, I think is there two groups in there? No, there's one group or one panel, so we'll do that. We haven't done the group or panel example, so in the next one we should be doing, I think there's a group here. Sorry. I'm just looking at our next example here. So in the next video we'll be doing the lab, which is pretty much just a form. It should have a group or a panel in there because we haven't done that yet. So thanks for watching, guys. Hopefully I'll see you guys in the next one. If you guys like the video, you can like and subscribe to the channel. Thanks for watching. I'll see you guys in the next one. Take care.